So this is the 2019 AP Chemistry Free Response questions, and this is number 6. And it says nitrogen dioxide is produced as a byproduct of the combustion of fossil fuels in internal combustion engines. At elevated temperatures, nitrogen dioxide decomposes according to the equation below. The concentration of a sample of nitrogen dioxide is monitored as it decomposes and is recorded on the graph directly below. The two graphs that follow it are derived from the original data. And part A says to explain how the graphs indicate that the reaction is second order. So the first step is that you have to identify which one of these is linear, right? This obviously isn't linear. The line of best fit is not exponential, but it's to a degree of -2 or -1, I believe. -2. No, definitely -1, but that doesn't matter. This one, again, obviously not linear. It's very much concave up, but this one is very much linear. And part A, explain how the graphs indicate the reaction is second order. The only justification you need is the reaction is second order because the graph of 1 over concentration versus time is linear. And that's it. That's just something you have to memorize, which kind of sucks. But that's just how it is. So part B says write the rate law for the decomposition of gaseous nitrogen dioxide. A second order, and the only reactant is NO2. So the rate law, rate is equal to the rate constant times the concentration of NO2 to the power of whatever order the graph is, or whatever order the reaction is, and that's it too. And that's it for part B. Part C, consider two possible mechanisms for the decomposition reaction. Is the rate law described by mechanism 1 shown below consistent with the rate law you wrote in part B? Justify your answer. The answer is yes, because whenever you're looking at the rate law that corresponds to the overall reaction from the mechanism, you have to look at the slowest step and use the coefficient of the reactant on the slowest step. And this is clearly just 2NO, right? So the reaction rate, in this case, in intermediate steps, is going to be the rate is equal to the rate constant times that concentration times, or raised to whatever power the coefficient of the product, or of the reactant, right? So that's simply rate equals K times concentration of nitrogen dioxide squared. So yes, it is consistent. Mention the slow step, the rate of the slow step matching the rate of the overall reaction, which is K times concentration of nitrogen dioxide squared. And part 2 says, is the rate law described by mechanism 2 shown below consistent with the rate law you wrote in part B? Justify your answer. So if you're not reading carefully, you answer no, right? Because the slow step has N2O4, or rate equals K times N2O4, right? And while this would be normally the reason that it's not consistent, it is consistent. And the reason with that is because of this fast equilibrium step. You have to recall what equilibrium means. Equilibrium means the rate of the forward reaction is equal to the rate of the reverse reaction. So this means that this rate, K1 times NO2 squared at equilibrium, is equal to the rate of this reaction, N2O4. And yeah, that's simply it. So although this is the rate of the slow step, that also equals this in equilibrium, and the system reaches equilibrium very quickly. So this will quickly become true. So, and this is obviously consistent with part B. So yes, that one also checks out. Explain how the two rates will equal each other at fast equilibrium, and that's why you substitute that term in for the slow step. That's why it's consistent. And that's it for part 6.